SN1 mechanism takes place in the presence of polar protic solvents like water, alcohol, acetic acid. The nucleophile OH- attacks carbocation to form tertiary butyl alcohol. The compounds which rotates the plane polarized light to the left or in anti-clockwise direction, they are called as what? Levorotatory. For nucleophilic substitution, there are how many types of mechanism? 2 types of mechanism. Reaction is different, reaction mechanism is different. Hello, my dear student. I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Today, I am going to deal with 4th session of chapter Haloalkanes and Haloarenes. 4th session of chapter Haloalkanes and Haloarenes. The previous session, that is in 3rd session, I discussed about the physical properties of haloalkanes and haloarenes, physical properties of haloalkanes and haloarenes, as well as chemical properties of haloalkanes and haloarenes. Under chemical properties, I discussed nucleophilic substitution. How alkyl halide undergo nucleophilic substitution with several reagents like aqueous potassium hydroxide, alcoholic potassium cyanide, alcoholic silver cyanide, etc. Okay. In today's class, I am going to discuss about substitution nucleophilic unimolecular, substitution nucleophilic bimolecular, stereochemical aspects of nucleophilic substitution reactions, that is SN1 in optically active alkyl halides, SN2 mechanism in optically active alkyl halides, and order of reactivity. Today's class, it completely deals with SN1 mechanism as well as what? SN2 mechanism and its stereochemistry or stereochemical aspects. Today's class, it completely deals with 2 mechanisms, SN1 mechanism and SN2 mechanism, and the stereochemical aspects of SN1 and what? SN2. You know that alkyl halide undergo nucleophilic substitution reaction. For that, you have to write reaction mechanism. Nucleophilic substitution reaction has been found to proceed by 2 types of different mechanism. For nucleophilic substitution, there are how many types of mechanism? 2 types of mechanism. Reaction is different, reaction mechanism is different. Nucleophilic substitution reactions are explained by using 2 types of mechanism. One is SN1 mechanism, SN1 mechanism. Second one, SN2 mechanism, SN1 mechanism and SN2 mechanism. What are the 2 mechanisms of nucleophilic substitution reaction? The 2 mechanisms of nucleophilic substitution reaction are SN1 mechanism and SN2 mechanism. SN1, S stands for substitution, S stands for substitution, S stands for substitution. N nucleophilic, N nucleophilic, N nucleophilic. 1 stands for unimolecular, unimolecular, unimolecular. Okay. SN2 means substitution nucleophilic bimolecular, substitution nucleophilic bimolecular. My dear student, nucleophilic substitution reactions are proceeded by how many mechanism? 2 mechanism. One is SN1 mechanism, second one SN2 mechanism. What is the expansion of SN1 mechanism? Substitution nucleophilic unimolecular, substitution nucleophilic unimolecular. This is substitution nucleophilic bimolecular, substitution nucleophilic bimolecular, substitution nucleophilic unimolecular and substitution nucleophilic bimolecular. Dear student, for board exam, out of these 2, 1 question compulsory for 3 marks. Either they will ask explain SN1 mechanism with example or SN2 mechanism with example. Therefore, so nucleophilic substitution reactions are explained by using how many mechanism? 2 mechanism. First one SN1 mechanism, second one SN2 mechanism. First one, I am going to explain SN1 mechanism. SN1 mechanism. SN1 mechanism generally takes place in the presence of polar protic solvents. They takes place in the presence of polar protic solvents. Polar protic solvents like water, alcohol, acetic acid. SN1 mechanism takes place in the presence of polar protic solvents like water, alcohol, acetic acid. This mechanism consists of two steps. SN1 mechanism consists of two steps. It can be explained by taking an example of tertiary butyl bromide. Tertiary butyl bromide. Okay. Tertiary butyl bromide is written as CH3 thrice CBr. CH3 how many times? 3 times, and bromine atom is attached to carbon. It is known as tertiary butyl bromide. Tertiary butyl bromide is trivial name. IUPAC name. When you consider this as a parent chain, it is numbered as first carbon, it has second carbon, and it has third carbon. In second carbon, there is bromine atom as well as methyl group. Therefore, what is its IUPAC name? 2-bromo, 2-methyl propane. 2-bromo, 2-methyl propane. So, what is the trivial name? Which one is I am taking example to explain SN1 mechanism? SN1 mechanism is explained by taking which one as an example? Tertiary alkyl halide, that is tertiary butyl bromide. What's the IUPAC name of tertiary butyl bromide? The IUPAC name of tertiary butyl bromide is 2-bromo, 2-methyl propane. 2-bromo, 2-methyl propane. Now, take tertiary butyl bromide heated with aqueous potassium hydroxide. It undergo hydrolysis with aqueous KOH. Here in tertiary butyl bromide, which is nucleophile? Bromine atom. Here which is nucleophile? OH. Therefore, bromine atom is replaced by OH group. Therefore, it will become CH3. In place of Br, it will come OH plus KOH become KBr. It will become tertiary butyl. Alcohol. It is tertiary butyl bromide, and it is tertiary butyl alcohol. Therefore, example, when tertiary butyl bromide undergo hydrolysis with aqueous KOH to form tertiary butyl alcohol by SN1 mechanism. This mechanism consists of how many steps? 2 steps. How many steps are present in SN1 mechanism? 2 steps. What are that steps? There are how many steps in SN1 mechanism? 2 steps. Step 1 and step 2. Okay. Now, what's the step 100? This tertiary alkyl halide undergo slow ionization to form carbocation and halide ion. See, my dear student, this is tertiary butyl bromide, CH3, Br. It undergo slow ionization. To form tertiary butyl carbocation, and bromide ion. What is carbocation? Carbon carrying positive charge is known as carbocation. This reaction is reversible. As well as slow. It is slow. Therefore, what's the first step of SN1 mechanism? The first step of SN1 mechanism, the tertiary butyl bromide undergo slow ionization to form carbocation and bromide ion, and this reaction is reversible and slow. Next, step 2, the nucleophile OH minus attacks carbocation carbocation to form tertiary butyl alcohol. The nucleophile OH minus attacks carbocation to form tertiary butyl alcohol. Now this is tertiary butyl carbocation. Tertiary butyl carbocation. Tertiary butyl carbocation. Nucleophile OH minus attacks this tertiary butyl carbocation from any direction, either from front or either from back or either from the top. Why the attack possible from any direction, any side or any direction? This carbocation is sp2 hybridized. Carbocation is sp2 hybridized. Carbocation is sp2 hybridized. This carbocation is sp2 hybridized. When it is sp2 hybridized, it has planar structure. It has planar structure. When it is sp2 hybridized, the carbocation has which structure? Planar structure. When it has planar structure, attack of this nucleophile takes place from any side and it will form tertiary butyl alcohol. And it form tertiary butyl alcohol. Therefore, SN1 mechanism consists of two steps. Step 1 and step 2. Step 1 is ionization. Step 2 is attack of nucleophile. Step 1 is ionization. Step 2 is attack of nucleophile. Carbocation is which type hybridized? sp2 hybridized. Therefore, it has which type of geometry? Planar geometry. Attack is possible from any side or any direction. Any side and any direction. First step is reversible as well as slow. Second step is irreversible. Second step is irreversible. Next. Now, why I consider? In chemical kinetics, we know that any chemical reaction takes place by 2 or more steps. Such reactions are called as complex reaction. When any reaction takes place by 2 or more steps, you have to consider slowest step. Why is the slowest step? Slowest step of a complex reaction is called as rate determining step. Is called as what? Rate determining step. Now here, in case of SN1 mechanism, which step is called rate determining step? Because step 1. Step 1. Why step 1 is? Already I mentioned that step 1, tertiary butyl bromide undergo slow ionization. Therefore, out of step 1 and step 2, which one is slowest step? Step 1. Therefore, step 1 is called as what? Rate determining step. In that step, only which one is involving? Alkyl halide. Nucleophile is involved in which step? Step 2. In step 1, only which one is involving? Alkyl halide. And how many molecule? 1 molecule. Therefore, in this type of reaction, the rate of reaction depends only on the concentration of haloalkane and it is independent of concentration of what? Nucleophile. It depends only on concentration of what? Alkyl halide. Step 1 is step 1 is the slowest step. Hence, it is called rate determining step. In this step, only which one is involved? Only reactant molecule is, only 1 molecule of which one is involved? Haloalkane or haloalkane. Here, how many molecule is involved? Only 1 molecule. Therefore, it is unimolecular. Therefore, it is unimolecular. And in the power, it is 1. It is first order reaction. It is what? First order reaction. Therefore, SN1 mechanism is first order and unimolecular. First order and unimolecular. It takes place by how many steps? 2 steps. In that, step 1 is called as rate determining step. Why step 1 is called as rate determining step? Because it is the slowest step. In that step, only 1 reactant molecule, that is alkyl halide, is involved. Only 1 molecule. Therefore, it is called as what? Unimolecular. Therefore, SN1 mechanism, the rate of reaction depends on only the concentration of alkyl halide. It is independent of concentration of what? Nucleophile. Therefore, it follows first order kinetics. It follows first order kinetics. Next, SN2 mechanism. SN2 mechanism will consider which one as an example? Methyl chloride. Which one as an example? Methyl chloride. In SN1 mechanism, I had taken which one as an example? Tertiary butyl bromide. Tertiary butyl bromide. In SN2, I had take example methyl chloride heated with aqueous KOH solution. What's the formula of methyl chloride? CH3Cl. it is aqueous KOH. Here nucleophile is Cl, here nucleophile is OH. Cl is replaced by OH. It will form what? CH3OH, methyl alcohol. It will form the, what's the name of product? Methyl alcohol. Methyl alcohol. Methyl chloride is converted into methyl alcohol by heating with aqueous KOH. SN2 mechanism consists of only one step. SN1 mechanism consists of two steps. SN2 mechanism consists of only one step. So, okay. In one step only, the nucleophile OH minus attacks the carbon from the opposite side, from the back side or from the opposite side. The OH minus attacks the carbon atom from the back side or from the opposite side of the chlorine atom. In case of SN1 mechanism, the nucleophile OH minus attacks carbon from any direction. For that I had given reason. Why? Because the carbocation is sp2 hybridized as well as it is what? Planar. But in case of SN2 mechanism, the nucleophile OH minus attacks carbon atom from the back side or from the opposite side, that of what? Chlorine atom. And this is the three-dimension structure of methyl chloride. This is known as dash wedge. It is known as solid wedge. These are normal lines. So this dotted line is called as what? What is, my dear student? Dash wedge. It is known as solid wedge. It is known as what? Normal line. Now, what happens when OH minus attacks carbon from the back side of the carbon, which is exactly opposite that of the chlorine atom? The OH and Cl, they are partially bonded to carbon. This dotted line indicates that partial bonding. The OH and Cl atom both are partially attached to carbon, and this state is called as what? Transition state. This is called as what? Transition state. It is called as what? Transition state. See, mechanism. This mechanism involves only one step. When the nucleophile OH minus attacks the carbon, it approaches the carbon atom only from the which side? Opposite side or back side to the chlorine atom to form new COH bond. The formation of COH bond, breakage of CCl bond takes place simultaneously. There exists a transition state. Which state is existed? Transition state is existed in where the OH minus and Cl minus are partially bonded to the carbon, atom. So, here the OH and Cl are partially bonded to carbon. As reaction proceeds, COH bond becomes strong. Which bond becomes strong? COH bond becomes strong and CCl bond weaken, and it is detached to form Cl minus, Which bond will become strong? COH bond becomes strong, CCl bond is get detached. Therefore, methyl chloride to methyl alcohol, it is not a two-step reaction. From here to here, it is a single-step reaction. Okay. Here, how many steps is involved? Only one step. It is only called as rate determining step. Involves how many reactant? Two reactant in the same step. One is alkyl halide, another one is nucleophile. Another one is what? Nucleophile. Therefore, it is called as bimolecular. Rate of a reaction is directly proportional to molar concentration of the alkyl halide and molar concentration of the nucleophile. When you add power, 1 plus 1 is equal to 2. Therefore, it follows second order kinetics. As well as it is bimolecular. Therefore, what is the main difference between SN1 mechanism and SN2 mechanism? SN1 mechanism takes place by two steps. SN2 mechanism takes place by one step. SN1 mechanism is unimolecular. SN2 mechanism is bimolecular. SN1 mechanism follows first order kinetics. SN2 mechanism follows second order kinetics. Next. Now, the main topic, stereochemical aspects of nucleophilic substitution reaction. Now, I discussed about mechanism of nucleophilic substitution by SN1 as well as what? SN2. Now, I am going to explain stereochemical aspects of nucleophilic substitution reaction. Some basic stereochemical principles and notations. If you want to know about stereochemical aspects, you require some basic terminology, basic principles as well as basic notations. First, optical isomerism. You know that isomerism, in first PUC you studied about isomerism. In isomerism, two types of isomerism, structural isomerism and stereoisomerism. In structural isomerism, there are 5 types: chain isomerism, position isomerism, functional isomerism, metamerism, tautomerism. In case of second type of isomerism, that is stereoisomerism. How many types of isomerism? 2 types of isomerism, structural isomerism as well as what? Stereoisomerism. In stereoisomerism, there are 2 types. One is geometrical isomerism. Second one is optical isomerism. What are the 2 types of stereoisomerism? The 2 types of stereoisomerism, geometrical isomerism and optical isomerism. Geometrical isomerism we studied in the first PUC, that is under hydrocarbon chapter. We studied about geometrical isomerism. Now in second PUC, we are going to study about optical isomerism. What is optical isomerism? Let us consider 2 or more compounds. They having same molecular formula and same structural formula. They have same molecular formula and structural formula. Molecular formula as well as what? Same molecular formula as well as what? Same structural formula. But how they differ with respect to each other? They differ in the direction of rotation of plane polarized light. They differ only with respect to the direction of rotation of plane polarized light. Plane polarized light. 2 compounds having same molecular formula and same structural formula. But how they differ with respect to each other? They differ with respect to the direction of rotation of plane polarized light. Such compounds are said to be optical isomers, and the phenomenon is called as what? Optical isomerism. My dear student, what is optical isomerism? When two compounds having same molecular formula and same structural formula, differ in the direction of rotation of plane polarized light, they said to be optical isomers, and the phenomenon is called as optical isomerism. Next, the property of the substance to rotate the plane polarized light is called optical activity. That property of that substance which rotates the plane polarized light, that property is called as what? Optical activity. For example, I will consider the plane polarized light traveling in straight line. If the plane polarized light rotates to the right side or in clockwise direction, or it rotates to the left side or in anti-clockwise direction. When plane polarized moving in a straight line, either it rotates to the right side or it rotates to the left side. If the compound rotate the plane polarized light to the right or clockwise direction, to the right or clockwise direction, they are called as dextrorotatory. They are called as what? Dextrorotatory, or D compounds are plus compounds. D compounds are plus compound. Alige, my dear students, what are dextrorotatory compound? These are the compound which rotates the plane polarized light to the right or in clockwise direction. They are called as dextrorotatory. They are indicated by Dr plus. Therefore, they are called as dextrorotatory compound. D compounds are plus compound. If the light, plane polarized light which rotates to the left to the left or in anti-clockwise direction. Anti-clockwise direction, they are called as levorotatory or L compounds or minus compounds, or minus compounds. Okay, therefore what are dextrorotatory and what are levorotatory? In optically active compound there are how many types? 2 types, dextrorotatory and levorotatory. What are dextrorotatory compound? These compound rotates the plane polarized light to the right or in clockwise direction. The compounds which rotates the plane polarized light to the left or in anti-clockwise direction, they are called as what? Levorotatory. Therefore, 2 terminologies or notations are very, very important in stereochemistry, dextrorotatory as well as levorotatory. For example, if I write plus glucose, it indicates glucose is a dextrorotatory. If I write minus fructose, fructose is a levorotatory. Okay. Therefore, in optically active substances, my dear student, once again I'll tell you, dextrorotatory and levorotatory. Dextro right, levo left. Okay. So now after that, you want to learn about one type of carbon in stereochemistry. For example, I'll consider methane. There is a structure of methane. Methane attached, as you know, carbon is tetravalent. It is attached with 4 same hydrogen atom. Now I'll consider one compound. CCl, Now observe this carbon. It is also attached with 4 atoms. But all the 4 atoms are different. Observe example 1 and example 2. In example 1, all the 4 atoms are same. They are hydrogen atoms. Here, the 4 atoms are different. One is chlorine, another one is bromine, another one is iodine, another one is hydrogen. If the carbon which is bonded to 4 different atoms, 4 different group of atom, it is called as chiral carbon or asymmetric carbon. It is denoted by asterisk. Okay. So what is chiral carbon? The 1 mark, very, very important question, my dear student. What is chiral carbon? Chiral carbon is a carbon which is attached with 4 different atoms or 4 different group of atom. Such carbon is known as what? Chiral carbon. What is the other name of chiral carbon? Asymmetric carbon, or it is called as stereogenic carbon. Therefore, in future you should be able to find out which carbon is chiral. What is chiral? How do you identify chiral carbon? The 4 atoms or 4 group of atom which are attached to the carbon, if they are different, then that carbon is called as which carbon? Chiral carbon or asymmetric carbon or stereogenic carbon. Now, chiral. Now observe this compound here. It is a 3-dimensional structure. Here, this carbon, it is attached with methyl, OH, H, CH2, CH3. All the 4 groups are different. Therefore, this molecule is chiral and the property is known as chirality. Because all the groups are different. They are non-superimposable on their mirror image. On the mirror image, they are not superimposable. They are non-superimposable mirror image. Therefore, chiral molecules are non-superimposable on their mirror image. Next, you consider this one. Here, which one repeats twice? CH3 repeat twice. Therefore, this carbon is not called as chiral. As I explained earlier, any carbon is said to be chiral. All the 4 groups of atom as well as atom must be different. But here, methyl repeat twice. Therefore, this carbon is not chiral. It is known as achiral. It is known as what? Achiral, which are superimposable on their mirror images. They are superimposable on their mirror images. Example, 2-propanol. Therefore, chiral molecule and achiral molecule. Chiral molecules are non-superimposable on their mirror images. Chiral molecules are non-superimposable on their mirror image. Achiral molecules are superimposable on their mirror image. Now, next topic, enantiomers. Enantiomers. What are enantiomers? Enantiomers are the pair of molecule. Enantiomers are pair of molecule which are non-superimposable mirror images of each other. Non-superimposable mirror images of each other. They are not superimposable. When I consider a pair of molecule, these are non-superimposable mirror images to each other. They are called as enantiomers, and the phenomenon is called as what? Enantiomerism. It's a very, very important question for 1 mark in your board exam. What is enantiomers? What are enantiomers? Enantiomers are pair of molecules. Enantiomers are pair of molecules which are non-superimposable mirror images to each other. This pair of molecule, how they differ with respect to each other andre, one molecule which rotates the plane polarized light to the right, another molecule rotates plane polarized light to the left. That means if one is dextrorotatory, another one is levorotatory. What is dextrorotatory? Which rotates plane polarized light to the right. What is levorotatory? Which rotates plane polarized light to the left. But however, both the compounds have identical physical properties like melting point, boiling point, solubility, refractive index. Alige enantiomers differ only with respect to the direction of rotation of plane polarized light. One compound rotates to the right, another compound rotates to the left. But when come across its physical properties, they have identical physical properties like melting point, boiling point, solubility and refractive index. Therefore, the very, very compulsory question for your board exam, what are enantiomers? Once again I will repeat, these are the pair of molecule which are non-superimposable mirror images are called enantiomers. Now, to understand stereochemical aspect, you require 3 terms: inversion, retention, racemization. Inversion, retention, racemization. What are the 3 terminologies I require to explain stereochemical aspects? Inversion, retention and racemization. Inversion, retention and racemization. Now you observe. If the reactant have some configuration, it is a carbon ABCX, stereogenic carbon atom. Okay. If I add Y, the X is replaced by Y. But there is no change in the relative configuration. Where there is X, in that position which one is come? Y. Therefore, it is known as what? Retention. Okay. When we consider during chemical reaction, if the product formed as opposite relative configuration, for example, see here, X is replaced by Y, but it goes to opposite to that of X. X here right side, but here Y side. Therefore, it is called as what? Inversion of configuration. It is also called as Walden inversion. If the configuration retains as it is known as retention. If the configuration is opposite to that of real product, it is known as what? Inversion. So, it is also called as what? Walden inversion. Okay. Now, racemic mixture or racemization. What is racemic mixture or racemization? I will take equimolar mixture of D and L isomer or mixture containing 2 enantiomers in equal proportions. Mixture containing 2 enantiomers. One enantiomer is dextrorotatory, another one is what? Levorotatory, as well as in equal proportion. When I will take dextro and levorotatory in equal proportion, So the optical, they have zero optical rotation. Why they have zero optical rotation? The rotation due to one isomer will be cancelled by the rotation due to other isomer. What dextrorotatory rotate to the right? So levorotatory rotate to the left. Therefore, the angle of rotation becomes zero. Angle of rotation becomes zero. Such mixture known as racemic mixture. A mixture containing two enantiomer. Two enantiomers is, one is in D form, another one is L isomer. In equal proportion, their optical rotation is zero, or they don't have optical rotation due to the rotation which is formed by one isomer is cancelled by other isomer. Such mixture is called as racemic mixture or racemization. Racemic mixture is denoted by DL or plus or minus. DL or plus or minus. DL or plus or minus. Okay. Now, when you consider any enantiomer into racemic mixture, conversion of enantiomer into racemic mixture is called as racemization. Conversion of enantiomer into racemic mixture. Conversion of enantiomer into racemic mixture. Racemic mixture is called as racemization. So, 1 mark, very important question. What is racemization? Conversion of enantiomer to racemic mixture is called as racemization. Okay. Now, in the same reaction, I'll show inversion, retention, racemization. Now, you will take this one. You will take this as a reactant. Okay. I'll add Y. Observe product A. Okay. In place of X, we have Y. Okay. There is no change in the configuration. Therefore, A is called as what? Retention. Next to the same, if I add Y comes here. It is exactly opposite to that of X. Not similar position. Opposite to that of X, Y come. Therefore, it is known as what? Inversion. Okay. If both A and B is formed, it is called as racemization. If only A is formed, it is called as retention. If it is only B is formed, it is called as inversion. Both A and B is formed, it is called as racemization. In observe A, there is no change in the position of X and Y. Where there is X, which one is come? Y. But here, where there is X, Y is not comes there. Exactly opposite position, Y will come. Therefore, it is called as inversion. It is called as what? Inversion. It is called as inversion, and it is called as retention. And it is called as what? Retention. Both A and B is called, it is called as what? Racemization. It is called as what? Racemization. Okay. Now, next topic, SN1 mechanism in optically active alkyl halides. SN1 reactions always accompanied by racemization. SN1 mechanism alli enagutte? Racemization agutte. Andre racemization andre both retention and inversion takes place. Retention matte inversion eradu agutte. Elli SN1 mechanism alli. Adike adannu enanta karitive? Racemization. Carbocation form is sp2. Nan already helide. SN1 mechanism alli ಏನು form ಆಗುತ್ತೆ? Carbocation. This carbocation is sp2 hybridized and it is planar. Therefore, the attack of nucleophile may be accomplished by either side, resulting either from front side as well as from back side. So, it is from back side as well as it is from two types of attacks takes place, resulting. So, one is from front side, another one from front side and what? Back side. Why front side and back side both attack takes place? Because it is planar. Because it is what? Planar. Okay. So, observe here my dear student. So, nucleophile attacks from front side and nucleophile attacks from what? Back side. This is a compound is 2-bromobutane. It is 2-bromobutane. This will become minus butane to all. It will become plus butane to all. Okay. So, now therefore, it is one form 50% levo and 50% dextro. Therefore, both inversion and retention takes place. Therefore, it is called as what? Racemization. But in case of optically active alkyl halide, the product formed as a result of SN2 mechanism has the inverted configuration. Why it has inverted configuration? Because the nucleophile attacks side, opposite side or from back side In SN1 mechanism, the attack of nucleophile takes place either from both the side, front side as well as what? Back side. Therefore, 50% of D isomer form, 50% of L isomer is formed. Therefore, SN1 mechanism leads racemization. But in SN2 mechanism, nucleophile attacks only from back side. Therefore, here observe the OH minus attacks from which side? Back side. From which side? Back side. I will consider which one as an example? Minus 2 bromo octane. It will form plus octane to all. Now, what is the order of reactivity of various alkyl halides in SN1 mechanism and SN2 mechanism? In case of SN1 mechanism, tertiary alkyl halide undergo very fast because of high stability of tertiary carbocation. Tertiary carbocation is highly stable. That's why tertiary alkyl halides are very fast in case of SN1. But in case of SN2, methyl halides are react most rapidly. Therefore, in SN1 mechanism, what's the order of reactivity? Tertiary, secondary, primary and methyl halide. In SN2, methyl halide, primary, secondary, tertiary. Observe here the order of reactivity of alkyl halide in SN1 and SN2 mechanism. For SN2, which one is methyl halide? Primary, secondary, tertiary. For SN1, which one is tertiary halide, secondary halide, primary halide. Therefore, what's the order of reactivity in case of SN1 mechanism? The order of reactivity of in SN1 mechanism is tertiary, secondary, primary, methyl halide. Adra reverse heli, this is the order of which mechanism? SN2 mechanism. For SN2 mechanism, methyl halide, primary, secondary, tertiary. What is the difference between SN1 mechanism and SN2 mechanism? It's a 2-mark important board question. Write two differences between SN1 mechanism and SN2 mechanism. Left side SN1, here SN2. SN1 2 steps, SN2 1 step. It is SN1 unimolecular, SN2 bimolecular. SN1 follows first order kinetics, it follows second order kinetic. Order of reactivity, tertiary, secondary, primary, methyl halide. In SN2, order of reactivity is methyl halide, primary, secondary, tertiary. Okay. So, therefore, in this class, I explained about all the mechanisms of nucleophilic substitution like SN1 and what? SN2 and its stereochemical aspects and that the very important topic dextrorotatory and levorotatory, how SN1 mechanism takes place by 2 steps, SN2 takes place by 1 step, and what are the differences between SN1 and SN2 mechanism. Dear students, next session I will consider elimination reaction. Today I explained about nucleophilic substitution mechanism. Next class I am going to consider elimination reaction. Okay. Next session I will consider about elimination reaction. Until that, goodbye. Thank you.